Hello, Algebra 1 students, and welcome to your 6th 3 video on exponential growth and decay. One video here, not too many slides, but very important information on what we call exponential growth and decay. So again, growth means getting bigger, decay means getting smaller, and again, we're doing it in an exponential way. So let's get started. Okay, example 1, it says exponential growth. It says the population of Hillville grows at an annual rate of 15%. What will the estimated population of Hillville be in 5 years? So when you see grows and you see this percentage rate, this means exponential growth. Okay, so if you take a look down here, right, exponential growth. Right, now this right here, this formula is our regular exponential function formula, right? But when we're growing, right, this b value is going to be greater than 1. And how we get that is by using this rate, which we call the growth factor, and replacing the b, which is right here, with this 1 plus r, right? That is very important. This whole growth factor, right? 1 plus r, that's what makes it exponential growth. All right, so I'm going to write it over here since I put a box. So f of x equals a, your initial amount, times 1 plus r, right, that's an r, to the x. All right, very important formula here, okay, that we need to try to remember, okay, right here. Now, let's talk about a couple things and how we're going to input this, right? So this 1 plus r, right, actually means 100% plus our rate as a percentage, but just changed into a decimal. All right? So when we handle this 1 plus r, and again, that's an r, sorry. When we handle that, we're going to handle it like this, and then we're going to change it into a decimal form. And we'll talk about that right up here. Okay, so if we take a look at how we're going to use this formula, I'll change the blue. So f of x equals a times 1 plus r to the x. So I need an initial amount. Well, on the sign, it says that the population of Hillville right now is 5,000. There is your a value. That's your initial amount. So f of x equals 5,000. And now the 1 plus r, I'm going to handle it right down here. I'm going to write 100%, because that's what 1 is as a percentage, plus, and the percent they gave us was 15%, plus 15%. I'm going to add those, and again, I think you can do that. That's 115%. And now we need to change this into a decimal. And to change that into a decimal, we're going to move the decimal place, which is after the 5, 2 places left, boom, boom, which means we go right after the first 1, 1.15. This is going to be what goes in that parenthesis, 1.15, 1.15. And then x is going to be your time. Now this x, stays x for a minute, that is my function, right? So that is the growth, the population growth function for Hillville. But now it gives me this 5 years, 5 years. That is what x is, because x is a time, right? 5 years. So we're going to replace the x with 5. So I'm going to do f of 5 equals 5,000 times 1.15 to the 5th power. And I could care less about this side, the left side. I'm going to type the right side into Desmos, and we're going to round to the nearest person. Okay, we're going to do this in Desmos right now. So 5,000 times 1.15 to the 5th. So I'll go back to here. 5,000 times 1.15, and they 1.15. And again, to get the exponent, you can do Shift 6 or use the A to the B button, and we'll put 5. Okay, and if I want to round this to the nearest whole person, so the 6, we have the 7 rounds the 6 up to a 7. So I would say about 10,057 people, right? That's your population. Again, Again, the comma is not mandatory. Okay, perfect. All right, so that was exponential growth. Okay, all right, we're back to here. All right, next one. It says a video is labeled a fan favorite if it receives at least 1,000 views per day. Amelia posts a video that gets 8,192 views on the first day. The number of views decreases by 25% each day after that. In how many days? In how many days total will the video stop being a fan favorite? So let's talk about a couple things, right? So first off, I see in my words decreases by 25%. That means that this is exponential decay. Now look here, exponential decay. All that means is that your b value is less than 1. Okay? It's going to be typically a fraction, right? It's got to be positive, so it's above 0, but it's going to be less than 1. Which means this b value in the original exponential function model is going to be replaced with 1 minus r. So here is now our exponential decay formula, 1 minus r. And again, we're going to do 100% minus r% to get our number, and then change it into a decimal. Okay? Okay, so if we take a look at this problem now, right? So let's build the function first and then talk about what this problem is actually about. So in blue, I'll write down the function. So f of x equals a times 1 minus r to the x. So a is the initial amount, and that is how many views she had on day 1, which they call day 0, right? So this is my a value. So f of x equals 8192. And then to take care of the parenthesis up here, I'm going to do 100% minus my rate that I'm decreasing by, which is 25%, and that is 75%. And now, if I move that decimal 2 places left, now the decimal's in front of the 7. Our decimal version is 0.75. That goes in place of the entire parenthesis, 0.05. And now we have to the x. So this is our decay function for this video. And now, this problem is saying that you no longer are a fan favorite, right? If you drop below 1,000, because to be a fan favorite, you have to have at least 1,000 views, which means you have to be greater than or equal to 1,000 views per day. So what we want to do is we want to continue this table, right? Notice, see how your numbers are going down, right? We want to continue this table and see when the views drop below 1,000. Well, to do this, we're going to do a fancy thing in Desmos, right? Now, in Desmos, we need to take this entire function and type it in, okay? All right, so let's do this. As we're doing this, notice that I'm trying to find time. So notice that I'm not plugging in anything for x because I'm trying to look for the time, okay? So 8,192, parentheses 0.75, again, raised to the x. And now I'm going to teach you this really fun and helpful thing in Desmos. So this button right here, it's called the edit list, but I think it's like the settings button. If I click on that gear button, you see this little table icon? I'm going to click on that table icon. What this is doing, and this now just created a table of values for this function, right? If you look at your notes, right? 08192, 16144, 24608. So it's the same table. So I'm going to go over here to this 2, and I'm going to have it highlighted. I'm just going to press enter, and look what happens. It spits out the next one: 33456. 42592. What I'm going to do is I'm going to keep clicking enter until my x value goes below, until my y value goes below 1,000. That'll be the number of days it takes to no longer be a fan favorite. Not below 1,000. Not below 1,000. Getting closer. I pressed the wrong button, sorry. I messed it up, I apologize. So 6, 7, I messed it up, sorry, 8. Oh, and there you go, right? 8. There is the first time it drops below 1,000, right? It goes from 1,093 to 820. So what I would like you to do is on your paper, I would like you to write down both of those ordered pairs. So on your paper, you should write down, so 71093.5 and 820.125. And therefore, it takes 8 days. 8 days for our video to no longer be a fan favorite. Perfect. Okay, last slide here. Okay, so it says, Rich is comparing the cost of maintaining his car with the depreciation value of the car. When will the cost and value be the same? Okay, so we actually have two functions we're talking about right now. So if you look at this left-hand side, this is the value function. Starts at 20,000 and decreases by 15%. Okay, so this is going to be exponential decay. So we're doing f of x equals a 1 minus r to the x. And over here for the maintenance cost, 500 for the first year and increases by 28%. This is going to be growth. Now I'm going to call it g of x. Just use a different function name. Doesn't really matter, right? That gf doesn't matter. So g of x equals, but now it's going to be a times 1 plus r to the x. All right, so let's build our two functions. So I'll do the value function in red. So the initial amount is this 120, or I'm sorry, is this 20,000. So the 20,000 is a, okay? And then to find this 1 minus r, we're going to do 100% minus 15%, which is 85%. But when you move the decimal over 2 decimal places, you get 0.85. So this function is going to be f of x equals 20,000, no comma please, times 0.85 to the x. Okay, there's our first function. Okay, I'll do the second function in blue. Okay, so now we're going to do g of x. Oh, sorry. Let's write down our numbers. So 500 is our a value. Let's find the 1 plus r. So it's 100% plus 28%. That equals 128%. Which then, if you move the decimal, becomes 1.28. So your maintenance function, g of x, is going to be 500 times 1.28 to the x. And now, we recently finished topic 4, which was on system of equations. When you see this word the same, right, that means equal. We want to know when these two functions will be equal. What will the cost be? And what will the value be, or when will the cost and value be the same? When is looking for a time, and time is your x. So what we're doing is we're trying to see when do these two graphs cross or intersect, right? And let's identify the x value or the time when that happens. And to do that, we're going to use Desmos, Ohio. Okay, so I'm going to erase this. This is going to go away. Okay, so we're going to finish our video in Desmos, Ohio. So again, I'm going to delete this stuff. Okay, so I'm going to type in my first function. So f of x equals, it was 20,000 times 0.85 to the x. And you're saying, hey, there's no graph showing up. Well, yeah, 20,000 is a huge number, so just chill, right? Let's do the other one, g of x equals, so 500 times 1.28 to the x. Okay, and again, nothing's happening. Well, 500 is a big number. So now I'm going to zoom out slowly. Oh, there's the red one, and it should show up first because it's 500 or smaller. Now notice it's growing because it's going up and to the right. Oh, there's a black one. Okay, so I'm going to keep zooming out, 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 keep zooming out. Okay, I'm going to drag it down. I'm going to click. Okay, boom, and there we go. Now that's a terrible graph, so I'm going to show you how the wrench, remember, can fix this. I think we did this earlier so we can see a good picture. So I'm going to go from 0 on the x to 20. So let's say in 20 years, right? And I'm going to go from 0 on the x to 20,000. Boom. And there you go, right? Like, how does he know that? Well, again, I just use the numbers here, and I think about how long you have a car for. You have a car for more than 20 years? I don't think so. So what I want you to do is on your paper is I want you to sketch this graph real fast, right? So I'm going to put an L-shaped graph here. We're going to have this graph going up like this. That is your g function. That's the maintenance. And then I want your other function to come down like this. And that is your f function. That's the value, right? And I want to mark this point where they intersect. And we're going to label it with its coordinates. So if you click on the graph, 94624. So this car, 94624. So after about 9 years, so you could say in about 9 years, the cost of maintenance and car value will both be about $4,624. And that is a great answer that every math teacher would appreciate, but if you just put in about 9 years, you'd get the answer right too, because it's usually the x value that you're looking for. Very important section here, right? So hopefully that all made sense. Can't wait to see you in class. Thanks for watching.